Right then, January 2013, paper 2, calculator paper, 2 hours allowed. Write down an expression for the cost of X pens and Y rulers. Okay, so pens are 15 pence each, so X of them will be 15X. And rulers are 20 pence each, so Y lots of them will be 20Y. 15X, add 20Y. A school buys 150 pens and 90 rulers. The total cost is reduced by 1/5. How much does the school pay? Okay, so you could either take a fifth off of these and then times it by your numbers, or work out your total costs and then take a fifth off, which is the way I'm going to do it. So, cost will be 15 times by your number of pens, 150, plus, I'll call that total cost, plus 20 rulers, which are, 90 rulers, which are 20 pence each. So 15 times 150. Remember, we're allowed a calculator on this one. 15 times 150 is 2250, and 20 times 90 is 1800. So that is going to be equal to 4,050 pence. Okay, so now 1/5 of 4,050 is 4,050 divided by 5, which is 810 pence to be taken off. So your total cost is 450 pence minus 810 pence, which is 4,050 minus 810, 3240 pence, which we can then write in pounds as £32 40 pence. So £32 40. AB is parallel to CD. Write down the size of angle X, give a reason for your answer. Right, if the question says give a reason for your answer, then you need to be given reasons, so supplementary, corresponding or alternate. Okay, the fact there's a star there means that's even more important. Okay, so we're trying to work out first the size of angle X. Angle X is here, and so hopefully you'll be able to see, well, there's our parallel lines, there and there, and if I draw a line across there, not very well, but you can see there's an F angle there, so X is equal to 108. Reason, well, we can't call it an F angle or F angle, we need the proper name, and the proper name is a corresponding angles are equal. What about the size of angle Y? I'm going to get rid of my F shape now that I've got. The size of angle Y is here. Okay, so again, if I've got myself two parallel lines and a line going between them, not a very good line, but a line nonetheless. I have to do that again. There we go. Then these two angles here, this one, this angle here, and this angle here, add up to 180 degrees. They're called supplementary angles. So Y equals 180 minus 117, which equals 63 degrees. Now admittedly it hasn't asked us to give a reason anywhere on part B, it just asks for part A, but because of the star there, and I think it's just a good habit to get into anyway, we can give reasons as to why we think things. So supplementary angles are add up to 180 degrees. So apart from the fact that I can't spell supplementary, we're done. Number 3. Jan wants to carpet her room. The room is a rectangle, length 5 metres by 3.6 metres. She uses this formula to work out the cost of the carpet. A is the area of the room, C is the cost. How much should the carpet cost? Okay, so first job then, well, we need A to be able to work out the cost. So that's the area, which on a rectangle is just base times width. For us that's 5 times 3.6. So that is 18 metres squared. So now we've got that there, we can now work out the cost. So the cost equals 50 times by A, which we just worked out to be 18, plus divided by 3, and then plus 45. So 50 times 18 first of all is 900. Divided by 3. 900 divided by 3 is 300, plus 45, which means the cost is £345. Then we're done. So work out the area first, and then you can work out your cost. Jack works 8 hours each day. He is paid £6.50 per hour. He shares his wages with Kim in the ratio 4:1. Jack saves his share. How many working days will it take Jack to save 1,040? Okay, so let's work out how much he earns per day first of all. And like, this question hasn't got a star by it, but it's the sort of question that might have. Okay, so you need to just be aware of that and keep it on yourself alert to that star question as you go along. So 8 times £6.50 is, I think, £52. Let's check that on the calculator. It's £52, yeah. Pay each day. So now he shares that in the ratio 4:1. So £52 in ratio 4:1. Let's do that. 4 add 1, you add your parts, is 5. Then you take your amount of money and divide by that, which is equal to, I believe, £10.40. Again, just going to check on the calculator. Yep. And so Jack gets 4 lots of £10.40, which is £41.60. So that's what Jack gets each day, is £41.60. So now once we've done that, we now want to know how many working days it will take Jack to save £1,040. So if we do 1,040 and divide that by how much he gets each day, then that'll tell us how many days he needs to work for. 25 days. And there we have it. Okay, 25. There's 5 marks for that. I guess 1 for working out this, a couple of marks here for working this out, and then 1 for making the division and interpreting your question right. Don't think that's too bad, hopefully. Number 5. Put the numbers 1, 2 or 3 on each card so that when a card is picked at random, we've got 2 rules. So it's just making sure both of these rules work, basically. So we've only got the numbers 1, 2 and 3, so we can't use any others. The probability of picking a 2 is greater than a half. Okay, so if it was greater than a half, then more than a half need to have the number 2 on them. So that could be 5, but then it could be 6, 7 or 8. I'm going to go with 5 first of all. If that didn't work, then I'll try 6, and I'll try 7. It won't be 8 because we need to have 1 and 3 somewhere. The probability of picking a 1 is twice the probability of getting a 3. Okay, so we've got 1, 3, then we'll have 2 1s to make up for that. So the probability of getting a 1 is then twice the probability of getting a 3. There we have it. We're done. It doesn't matter what order you write these numbers in, just as long as you've got that amount of each. Okay, these questions come up quite often. If you sort of look at them as a list and try and work your way through them, sometimes they're like on a spinner, and work your way through them like a list, then you'll get yourself to the answer. Work out the value of 7 cubed on a calculator question? Really? Okay, so 7 cubed is 7 times 7 times 7, which really you should be able to do without a calculator. But I've said you can do a calculator, so you can just type it into calculator and see. You might have a cubed button, or if not, 7 times 7 times 7, and your answer is 343. So hopefully that's alright. The sum of 2 consecutive cube numbers is 341. Work out the 2 numbers. Well, before I even start here, I'm going to make a list of what my cube numbers are. Okay, so 1 times 1 times 1, that's 1. 2 times 2 times 2, that's 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. Use a calculator, not wrong with that. 7 times 7 times 7, we've just done that, is 343. Now, I know I don't need to go any further than that because the sum means add. So 2 of these numbers that are next to each other add up to 341, so there's no point going further than that. So now it's just a case of trying to plug which 2 of these add up to 341. Because it's consecutive, it means they're next to each other. So 8 of 27, 35, no good. 27 of 64, it's clearly nowhere near. 64 of 125, 189, no good. Here we go, 125 of 216 is 341. So 2 consecutive, we'll work out the 2 numbers, 125, 216. So I don't think that question is too hard, but what they are doing is just making sure you know what cube numbers are. Okay, I think that could quite easily be a non-calculated question as well, really, because you need to be able to work out what these cube numbers are. Okay, so it's quite generous being on a calculator paper. Cube numbers you need to know. The diagram shows a kite. Aha! 4 of the kites are put together to make this shape. Work out the size of angle X. Okay, so the key to this then is that if we go back to our original kite here, we need to work out what each of these angles are in here. Now, because these are the same, we know that the top and bottom are the same. So this angle here and this angle here are equal to each other. The key is this angle here. So how am I going to work out where that little mark is there? How am I going to work that out there? Well, we've got 4 identical ones here around a point. And because angles around a point up to 360, we're going to do 360 divided by 4. So each of them is equal to 90 degrees. Okay? I think it's worth saying angles at a point add up to 360. I don't think it hurts to add that bit of information into there. Okay? So now, what we're going to do, we've got ourselves 90 degrees here, like so, and x and x and the other angle at the top there is x. Okay, so to work it out, we do 360 minus 36 minus 90, first of all. So that is going to be, again, get my calculator out, I think it's 234, isn't it? But it's worth checking. 360 minus 36 minus 90, 234, yep. Again, give a reason for that. Angles in a quadrilateral add up to 360 degrees. Okay, because it's a four-sided shape, so 360 degrees, and 234 divided by 2 equals 117 degrees. And why have we done that? Because remaining two angles on the kite are equal. So there's your answer, apart from the fact that it's taken up a bit of room. So your answer is 117 degrees. Okay. Again, I think this one, alarm bells to me was 4 marks straight away. As soon as I saw it was 4 marks, I know I'm going to have to do a bit of working out on that one. Okay, so not only am I doing it, but giving reasons as you go along as to why you've done them as well. Okay, if you know why you've done that, then write it down and tell them. Okay, so the examiner knows why you're doing things as much as possible. Okay, we've got a little island. The airport is on a bearing of 40 degrees from the hospital and 270 from the stadium. Mark the position on the map. Okay, so the key to bearings is 3 things. We always measure from north, which is why north is given to us. We always measure in a clockwise direction, and we've always got 3 figures. So rather than 40 here, they've put 0, 40. So you need to remember if you're doing an answer in bearings that you need to have 3 figures on it. Okay, so the hospital then is there. We put our compass, no we don't, put our protractor on the hospital with 0 going up through north. Then we draw a line going through at 40 degrees. So 40 degrees is there. So I know that my, whatever it is we're looking for, the airport is somewhere along that line there, because it's on a bearing of 40 degrees from the hospital. And now 270 from the stadium. Now the problem we've got a little bit is with our small protractors, half protractors, we only go around 180 degrees from here. So how many more degrees do we need to go? Well, we need to go 90 degrees further to get to 270. So another 90 degrees further is going to be there. So our airport is somewhere along there. Okay, so where do them 2 lines then cross? You should probably put a cross there, but I'm going to do a little blob just so we can see it fairly clearly. And then I'm going to colour it in a nice pretty orange colour with a purple edge, which is dotted. Oh, that's not so good. There we go. Alright, so yeah, alright, I'll slightly over the top there, and X would probably do the job. We'll get your pencil crayons out for that one. But hopefully that makes sense. Again, 3 things with bearings, from north, clockwise, and 3 figures. Work out the length X. Well, it's a right angle triangle, so straight away I've got myself Pythagoras written down. So, Pythagoras goes like this. The long length squared is equal to the short length squared plus the other short length squared. So the long length squared plus the short length squared plus the other short length squared. So now what is 15 squared? 15 times 15, 225. 7 squared is 49, is x squared. And now the tricky bit is we need to take the 49 from this side, which means we need to take 49 from the other side as well. So I'll take 49 off there, I've got to take 49 off of there. Okay, so 225 minus 49 is equal to 176. And so x is equal to the square root of 176 which is equal to, get my calculator out, square root 176 is 13.26649916. So there's your working out. Oh, that's the question. There's your working out. You then just need to make sure you round your answer to something sensible. So I'm going to go 13.3 to 3 significant figures. That's my answer. Okay. Now I've done quite a lot of working out for that one. Probably don't need to do quite as much working out as that, but I would go as far to write down the rule first of all and substitute them in. Personally, just go for a step by step. Okay, we'll get you to the answer, I would think. Okay, make sure you round something sensible at the end. If you leave this big answer here, then you're going to lose yourself a mark, because we don't need, is it 8 decimal places? That's a tiny little amount of a centimetre. Okay, so 3 significant figures is normally good. Have a look at the answer, make a decision. Translate the shape by the vector 2, 3. So translate just means to slide the shape along. The key to this is knowing that the top number is your left and right, and your bottom number is up or down. Okay, so the top number, left or right 2, well, positive 2 means we go to the right, negative 2 means we go to the left. So I'm going to go 2 to the right, and then we go in 3, and that will be 3 up rather than 3 down. Negative 3 will be 3 down. So 1, 2, 3. There we go. Describe fully the single transformation that takes shape A to shape B. Okay, I always think with these ones, you've got to be careful that you go in the right way. So we're going from A to B. Just make sure you look at that carefully, because sometimes sometimes it's easy to make that mistake. So first job, we need to say it's a rotation. And the second job, we need to say how far we're rotating it. Well, it looks to me like a 90-degree rotation. And what direction? Clockwise, with the centre for 3. Okay, so we've got to put them 3 things for rotation. We'll first say it's a rotation, and then you have to say how far, clockwise or anti-clockwise. The only time you don't need is 180 degrees, because then it doesn't matter. Okay, so 90 degrees clockwise, and then you need to take the centre, the point that it's spun round. I can't demonstrate this too well on here, but I'd be getting myself some tracing paper and just trying lots of points out. So I go here, I'll spin 90 degrees, well that's going to bring me to about here. So you keep spinning around until you get the point that you spin around that takes you exactly from one shape onto the other. Hopefully that makes sense. If not, you know who to ask. Number 11. An ordinary dice is rolled 120 times. How many times would you expect to roll a 6? Well, how many sides does a dice got? 6. So I think 120 divided by 6 will tell us how many we'd expect to get. 20 times. Now, I very much doubt if you did it 120 times you get exactly 26s, but that's your expected frequency, your expected amount. 12. Samples are taken from a production line. The number of faulty items is shown. Star, star, star. See the star? Which sample has the biggest proportion of faulty items? You must show your working out. Okay, so just set your work out in a sensible way. What we're going to do then is, if we're talking about proportions, then the easiest way is to look at it as a percentage. Okay, so if we do sample A, we can say there are 42 faulty items out of 300 in total. So 42 divided by 300, and then times by 100 is going to give us that as a percentage. 42 divided by 300 times 100 is 14%. Faulty. Okay, so what we do once we've done that is just do the same for each of the samples. There's sample A, shuffle it over there, and then we'll do sample B. I've been a bit lazy there, a bit of a cut and paste. So sample B, we've got 33 faulty items out of 250 in total. So to work that as a percentage, you do 33 divided by 250 times 100, which is 13.2% are faulty on that one. There's sample A. sample B, sample C. There are 48 faulty items, out of 400 in total, so we're going to do 48 divided by 400 times 100, which is, on our calculators, 12%. So there we do it. For that one, which sample has the biggest proportion of faulty items? So which one's got the biggest percentage? Sample A. Sample A has the highest proportion of faulty items. And then we're there. Okay. Now, I've probably overdone the working out a little bit, but the star makes me want to do that. There are other ways you could have done it. You could have made these all over the same amount. Now, that's fairly tricky to do, but you could make it out of 100, say. You could divide this by 100, so divide that by 100, divide by 2.5, and then divide by 4, and then compare them percentages, them amounts. Okay, so in other words, making your sample size the same amount, or different numbers. I went for the way I went for, but that's not necessarily the only way. Alright, that is the only answer though. 13. Expand and simplify. 2a plus 3 plus 5 minus a. I mean, it's just got to be careful with the minus signs on these, that's all. Yeah? So looking at the first bracket, 2 times a is 2a, 2 times 3 is 6, 5 times a is 5a, and 5 times minus 1 is minus 5. So you get to that point, and now 2a plus 5a is 7a, and 6 minus 5 is 1. So your answer is 7a plus 1. And yeah, that's going to come up, them sort of questions. Okay, they're kind of your gimme marks really, so you need to make sure you're getting them correct. These ones, again, aren't too bad. You've just got to times each of the things that are the same together. Okay, so there's 5 there, and there's no other numbers there. So my first job is to write down the number 5. Then we'll do it with the C's. I've got C4 times C2. Now you just got to remember that when you multiply numbers, multiply indices, you add the little numbers together. So I've got 2D's and 3D's. That gives me D to the power of 5. And there's my answer. Okay, so you can go straight to that. If you're not happy with that, you could do it in bits. That's 5 times C 4 times D twice. So that's 5C to the 4D squared. And then I'm going to times that by C squared and times that by D cubed. So that's the same as that. So now if I simplify that, I've got 5, and then I've got 6D's. So 6C, C to the power of 6, and 5D's, D to the power of 5. Hopefully that makes sense. Simplify fully. Again, the squared bit here, you must remember that we don't just square the numbers inside them. Squared means, as I've sort of done already over here, you times by itself. So that top bit, 8x minus 3 squared, is 8x minus 3 times x minus 3. So now to simplify it, all we do is we get rid of anything that's the same. There's an x minus 3 there and x minus 3 there, because when you divide anything by itself you get 1. And also the number. What is 8 divided by 4? Well, 8 divided by 4 is 2. So I can cancel that down and change it to 2. So now I'm just going to tidy that up a little bit. That's going to be equal to 2 lots of x minus 3, and on the bottom x plus 3. And then we're there. Okay, 14. Getting there, not too bad. Getting to the hard ones now, eh? So the diagram shows a box plot, write down the median. Well, the median is the middle bar on this box that we've got here. So that looks to me like that is at, the number 65. And the interquartile range, well, the interquartile range is your upper quartile minus your lower quartile. Your upper quartile is 80, your lower quartile is 26. So that is 54. So the answer to that is 54. Alright, just be careful with the scale on that one, and going up in twos for each box, so just make sure you're aware of that, but that should be fine. Number 15, factorise fully. I love factorising. Seems to cause some confusion sometimes though. So to factorise, we're looking for, we've got two terms here, we've got 4x squared and we've got 6xy. We're looking for things that are similar in both. So what number goes into 4 and 6? Well, 2 does. And what letter have we got in both? Well, we've got an x in both. So that's what we take outside of our bracket. Now what do we times 2x by to get to 4x squared? Well, 2 times 2 is 4, and x times x is 2x. And then 2 times 3 is 6. We've already got an x, and we need a y. So that there is our answer. Okay, so factorise just means to put a bracket back into it, essentially. Okay, and you can check that times that is the first term, and that times that is the second term. Alright. Solve. Okay, so for me, whenever you're solving and you've got fractions involved, you want to get rid of the fractions as soon as you can. Okay, because fractions tend to make things quite difficult. So to do that, we've got ourselves left side and right side of this equal sign. If we times this side by 4, that will get rid of the divide by 4 bit, but then we have to times that side by 4 as well. So, times on the left side by 4, you just get 2w minus 1, because you've divided by 4, so times by 4 is just going to get rid of that. And then this times by 4 is going to give you 4 out of that there. So now I'm going to expand this bracket that I've just written down, so 8 minus 4w is there. Now you could go straight to this line here, 2 times 4 is 8 and w times 4 is 4w, okay? Now we've got to solve this equation, and we're looking for the lowest number of our variable. So I've got 2w here, and careful, I've got minus 4w there. So what's lower than minus 4w? So we're going to add 4w to that side, add 4w to that side. 6w minus 1 equals 8. Now I'm going to get rid of the minus 1 by adding 1 to both sides. 8 plus 1 is 9. And then finally, I'm going to divide 9 by 6. And 9 divided by 6, I'll just check on my calculator because I don't want to make a silly mistake, is 1.5. So that's your answer to that one. Now we'll say, once you've got to this point here, that's not the only way of solving this. Okay, and if you've got to 1.5, then that's fine. I just think that's the easiest way, that's all. 16. 80 patients gave information about how long they waited to see the doctor. Work out an estimate for the mean time that the patients waited. Okay, so I don't know what these numbers are in here. All I know is that there are 5 people between 0 and 10, 22 between 10 and 20, 28 between 20 and 30, and so on. Okay, so if I want an estimate for the mean time, then I'm going to look at the midpoints of these, which is why they've given us extra columns. Okay, so the midpoint of 0 to 10 is 5, the midpoint of 10 to 20 is 15, the midpoint of 20 to 30 is 25, midpoint of 30 to 40 is 35, and midpoint of 40 to 50 is 45. So my first job is just to list the midpoints of these, okay? So now what I'm going to do is I'm going to say, well, 5 people took 5 minutes. I don't know it's 5 minutes, but that's the time I'm using. So 5 people took 5 minutes, 5 times 5 is 25. 22 people took 15 minutes, 330. 28 people took 25 minutes. 21 people took 35 minutes. 4 people took 45 minutes. Okay, so now how many minutes altogether have been waited? Well, if I add these together, that's going to tell me how many minutes were waited altogether. So add them together, get 1970. And how many people were there? Well, there's 80 people, tells us, or we can get that by adding together the numbers in that column. So my final job then is just to divide them numbers. So 19 divided by 80 is going to be 24.625 minutes. Okay. So I'll be rounding that thing to 24.6 here. It's worth saying what you're rounding to when you do things though. 3 significant figures. Okay. Right, the doctor says 70% of our patients weight less than 30 minutes to be seen. Is she correct? Okay. Well, to do that, our first job is to work out what 70% of the patients are, first of all. So 70% of 80 patients, because how many patients we've got, is 80 times 0.7, which is 56 patients. Okay, so 56 patients, that's saying 56 patients waited less than 30 minutes to be seen. So now looking at our frequency column, these numbers here, well, less than 30 minutes is up to that point there. So that'll be 5 add 22 add equals 55 patients waited up to 30 minutes. So the doctor's claim is correct. Okay. Please don't be tempted just to write yes there as an answer. Is she correct? Yeah. You've got to justify things. Even if yes is true, you won't get any marks for it. You have to make sure you justify it, okay? That might seem terribly unfair. It's not. Number 17. Show that all sides of this quadrilateral could be equal. Okay, so to get me going on this one, the first thing I've done is I've expanded my brackets out. So I've made that 6x minus 12, I've made that 3x plus 9. Okay, now we've got two sort of equations here we can solve, and you can do either one, but because the lengths are equal, I've got 7x minus 19 is equal to 3x plus 9. Okay, now equally I could have used 6x minus 12 equals 4x plus 2. Whatever tickles your fancy really. So now solving this, so I take 3x off this side, and then off the other side as well, I get 4x minus 19 equals 9. Add 19 to both sides, I get 4x equals 28. So finishing off, I divide by 4, x is equal to 7. Okay, so I can work out what x is equal to. I set myself up an equation, I can solve it, I know now x is equal to 7. Now I've got that, I can work out each side. Okay, so if x equals 7, 6x minus 12 is 6 times 7, which is 42 minus 12, which equals 30. And I can do that for each side. So 7x minus 19, or 7 times 7 is 49, minus 19, which is 30. That's a winner. On the next side, 4x plus 2, or 4 times x, is 28, plus 2, which is 30. This is looking good. And then finally, my last one I haven't done is 3x plus 9, or 3 times 7 is 21, plus 9, which is 30. So, when x equals 7, all the sides of the quadrilateral are equal. And there's our answer to that one. Okay, so we need to find a value of x, and once we've got that, we can then work out the length of each side, and we can then try and answer the question that it's asked us to do, show that all the sides are equal. We have. Okay, a couple of years ago there was a similar question where they said show that this quadrilateral could be a square, Okay, so it's sort of a bit more vague in how it worded it. But the same methods apply. Number 18. Draw a cumulative frequency diagram for the data. Okay, so I like cumulative frequency diagrams. All that means is like a running total. So in this end here, we're going to do like a running total. So we've got 2, and then we're going to add on the 3 and we get 5. Then we're going to add on 20, we'll get 25. Then add on 16, 41, and then we add on 9 and we get 50. There we go, like so. So it's just a running total of what we've got. And you should get it right if you've got this here, 50 students, and it comes to 50 over there. And the key to this is, whenever you do these, is you plot in 2 points. You plot in your cumulative frequency against your upper bounds. Okay, now the reason is because this is the number everything up to 60 is 2, everything up to 70 is 5, everything up to 80 is 25, so we use the upper bounds. Alright, so upper bound 60 goes 2, 60 goes 2, 70 goes 5, 80 goes 25, 90 goes 41, and 100 goes 50. Okay, so there's our answer. And the difficult bit, I kind of need a line that looks a bit like that shape there, an S shape. I'm going to struggle to do this a bit, but a curve, so not a dot to dot, but a nice curve linking these together. Went a bit low at the end there, I'm going to do that last bit again actually. Okay, no, we don't necessarily start there, we start on the lowest mark that someone could have got, which is 50. So we then go back to there, because that's the lowest that anyone could have got, was 50. Okay, students who score between 72 and 85 marks are chosen for extra lessons. Estimate the number of students chosen. So students who score between 72 and 85 marks. 72 marks is there. And 85 marks is there. So that's that. So estimate the number of students chosen. What we do is we're going to take these two numbers away, a bit like an interquartile range when we do them. So there's 32 pupils minus 8, which is 24 pupils in that section there, or students, pupils. Alright, again I would leave these lines on here as working out, okay, I wouldn't go rubbing them out. Okay, that's going to give you a mark that you're working out on that one. Alright, so don't feel the need to rub them out, that's fine, you can leave them on there. 19. These are the times for 200 people to get to work. A 10% stratified sample stratified by time is taken. Complete the table. Okay, so 10% means we're going to do a 10% sample. 10% of 200 is 20. So we're going to do 20 people in our sample. So first thing to do that, 10% of 200 equals 20. So that's how big our sample is going to be, 20 people. Now we do have a rule that says to work out how many we're going to have in each sample, we do the amount, divide the population, times by the sample size. So we do 7 divided by the population, which is 200, times by the sample size, which is 20. However, if it's just a 10% one, all we've really got to do is just divide by 10. So 7 divided by 10 is going to be 0.7. 21 divided by 10, 2.1, 78 divided by 10, 7.8, 64 divided by 10, 6.4, and 30 divided by 10 is going to be 3. So there's my 10% sample. Well, clearly, hopefully you're all seeing what the problem we've got here is that. I'll move them to the side. We can't have 0.8 of a person or 0.7 of a person, things like that, so we then need to do a bit of rounding. So 0.7 will round to 1, so 1 person from that group. 2.1 will round to 2. The 3 will keep as 3. I can manage that one. 7.8 will round to 8. And 6.4 will round to 6. Now before we go bombing on, it's worth just checking. We need 20 people in our sample, so these numbers have to add up to 20. 1 and 2 is 3, add 8 is 11, add 6 is 17, add 3 is 20. And often the question will do that. However, if they add up to 19, then you can then put an extra 1 in somewhere, okay? So maybe one of the ones you rounded down, you'd round up instead, okay? So 6.4 is closer to 7 than 2.1 is to 3, so you could change this to 7. And similarly, if they add up to 21, then we need to knock 1 off. It wouldn't be fair to take 1 off of the 0.7, so there's none in that section at all. Okay, so you'd probably take 1 off of the 7.8. Okay, so hopefully that makes sense. 20. R is inversely proportional to A. Okay, so these proportional questions, this is very much a routine, a method question really, or that's the way I see them. So R is inversely proportional to A. Well, there's our proportional sign, and inverse means it's 1 over A. So R is proportional to 1 over A, which means we use the equation R is equal to K over A, where K is our number that we've got to work out, our constant of proportionality. So once we've got that, we then use these two values here, because at some point R is 12.1 when A is 1.5, so I put them into this to get that. 12.1 is equal to K over 1.5. I can work out what K is by timesing them two together. So there's my K value, which is 18.15. So now to work out a formula connecting the two, I just use these two things. That's my starting point, but I now have this that I can add into that. Okay, so if I combine them two together, I get R equals 18.15 over A. Swap in my K for 18.15. Okay, so there's my formula that I've now got. Work out the value of R when A equals 4. So all I'm going to do is I'm going to swap my A equals 4 in here. There's my rule. I'm going to swap my A value for 4. So now calculate a job to finish off is, I don't know if I typed that in right, 18.15 divided by 4 is 4.5375, and that is what R is equal to. 21, £1,800 invested at 4% compound interest. How many years will it take for the investment to be worth £2,000? Okay, so 1,800 is what we had at the start of the first year. At the start, and to get after 1 year, we times by 1.04, and that will tell us what we've got at the end of that year. So after 1 year, we've got 1,000. Oh, that's annoying. Type that in again. Is £1,872. So after 1 year, I've got that. And after the next year, I'll times by 1.04 again. And that's going to be £1946.88. So I still haven't got to what I'm trying to get to. I'm trying to get to 2,000. So we do it again, times by 1.04 again. And we've got £2,024.76. So, how many years did it take to get there? Well, 1 year was that number, 2 years was that number, 3 years was that number. So it took 3 years to get over £2,000. The diagram shows the net of a square-based pyramid. So there's our net. And the area of the square base is 36. Work out the area of one triangle face. Oh, that's a good looking question. Alright, so first of all, 6 times 6 is 36. So this length here is 6 centimetres each side on the square there is that, because 6 times 6 is 36, so that's that there. Okay, so now if I'm going to work out the area of a triangle, of one of them triangles, then I need to do the base times the height, then divide by 2. And that's lovely, I've got the base, winner, but I don't have the height. So to do the height, what I notice down here, if I've got myself a triangle there, then that angle there is 70, and this length here is 3, and then I've got my height here to work out. So actually this is a trigonometry question. I've got 3 there, and I've got 70 in there. So that's 70 degrees, and that's 3 centimetres. And I'm trying to work out the height there. Okay, so trigonometry. So okay, so I'll write them down straight away whenever I'm doing myself a bit of trigonometry. Sokata. Okay, so now what do I know? Well, I'm trying to work out the opposite and know the adjacent and the angle in between there. So it's going to be the TOA one, it's going to be this one here, and I'm trying to work out the opposite because I've got the adjacent. So I'm working out the opposite, so tan times by A is going to give me what I need. So the opposite is h, the height is equal to tan 70 times by the adjacent. So calculate a job to find that out. Clear that. So tan 70 is going to be 221959918 times by 3 equals times 3, 3.6658795754. So now we'll round that to something sensible. Let's go 2 decimal places, 3.67. 3 different figures, centimetres. Okay, so remove that there. So now if I go back to the triangle, area of triangle equals base times height divided by 2. Okay, so for us, our base is 6 times the height, 3.67, divided by 2. So 6 times 3.67 divided by 2. 11.01 centimetres squared. And there we have it, there's your answer, 11.01 centimetres squared. That's a tricky question, that one. It's the sort of thing they're doing more and more often, really, where they're mixing together your area and your trigonometry and different rules at the same time. Okay, it's trying to pick off all the skills that you need to answer the question. Okay, well, hopefully that follows. 11.01 centimetres squared. Alright, next one then. Vectors. It's like Despicable Me, isn't it? So work out mn in terms of a and b. What have we got then? O to a is 4a, O to b is 2b, BC is given to us as b, and OM is given to us as 3a, that length there, and n is in the middle of them. Okay, so if n is the midpoint of AB, what we want to be working out is AB first, and then we can then half it to get our answer. So AB is equal to, and officially I should have a little arrow above them, but I don't have an arrow available to me, I'm afraid. A to B. Well, A to B, well, A to O is 4a, but in the opposite direction, so that's minus 4a. and then O to B is going to add 2B onto it. So that's what AB is. So Mn equals half AB. I think I have a little half button somewhere. It's half AB. So that is half what we worked out already, which was minus 4A plus 2B. And so half of each of them is going to give you minus 4A halved is minus 2A, and 2B halved is B. So there's your answer. Minus 2A plus B. Star going on there, show that M, N and C lie on a straight line. I think that's going to have to be another one that I'm going to have to come back to you on, I think. C, 3A, 3B there. 3 work out MN, and then C, that they're equal to the same thing. Right, I'm going to have to, I'll work that one out on paper and then come back and do that for you another time. Or pop your head up and come and see me and I'll explain it to you. Okay, we're nearly there. 24. Simultaneous equations. Give your answers to 2 decimal places. Right, for me, as soon as you see that there's a quadratic involved, and the question says give your answers to 2 decimal places, it means that you're going to need the rule that I've already put up here. You're going to need your quadratic formula. Okay, and now that's not just for simultaneous equation ones, that's just whenever you see a quadratic and it says give your answer to 2 decimal places, you're going to be needing that rule. Okay, so make a note of that. Right, so back to our equation. This one's going to be a tricky one, I reckon. I think we can do it. So whenever you've got simultaneous equations and one's quadratic, then basically you're going to substitute one into the other. In other words, this y equals 2x squared plus 3x minus 1. I'm going to swap my y for what I've got y is equal to up there. So I'm going to have x plus 4 is equal to 2x squared plus 3x minus 1. It's going to be my first job, so I'm going to make them equal to each other. Okay, now to solve a quadratic we need to have one side equal to 0. So I'm going to try and get rid of this x plus 4. So I'm going to take the x off first. If I take x off of this side, I need to take x off this side as well. So there it is, exactly the same. I'm going to take an x off, so it's going to be 2x. And finally, if I'm going to take 4 off of here, I'm going to take 4 off of there as well. So I get to that there. And then all I'm going to do, just finish off, is I'm going to turn that round to face the other way round, because I quite like to have my equals 0 on the right hand side, just so it looks familiar to me. Okay, so now we've got to solve this quadratic equation. Now we could factorise it, but I know that because it says to 2 decimal places here that it's not going to factorise. Okay, they might do, and they might be selling us a dummy, but they don't. Alright, so if it says give your answer to 2 decimal places, then it's going to be a quadratic formula one. Okay, well you can do completing the square. I know some of you can do that, which is fine, you can go for it, but I'm going to stick to quadratic formula today. Oh, lost it. Right, so it's probably over there. So now for my quadratic equation that we've got x equals minus b will be its 2, so minus 2. Then we've got a plus or minus sign, and then we're square rooting. Let's get it all looking the same. There we go. So then b squared, that's 2 squared, which is 4, minus 4 times a times c. So 4 times a is 2 and c is minus 5. So 4 times 2 is 8, times minus 5, minus 40. And that's going to be all over 2a. Well, a is 2, so 2 times 2 is 4. Now I've done that all in one go. You don't have to do that all in that one step. You can do that a bit more slow paced if you want to. So now 4 minus minus 40, or minus and minus is a plus, and 4 plus 40 is 44. So now to get our answer, we're going to do two things. Clear. So we've got minus 2 plus root 44, and divided by 4 is going to be 1.15831295, or if we take it away, so minus 2 minus root 44 and divide by 4, then we get minus 2.1583124. So they are the values that x could be. I will now need to round them to something sensible, so we'll go 1.16, 2.16. Alright, so take a little breather there. We've solved our equation. We're starting to look quite good. The only issue we've got now is we've got our x values. We just need to remember that we need y values to go with them. Okay, so our y values to go with them then are going to be our x value plus 4. So y is going to be 5.16, or it's going to be 1.84, and they're going to be our answers. Okay, I'll leave them over there. So 6 marks for that. That's a lot of marks. You're going to get yourself 1 or 2 marks to get to this point. You're going to get yourself another couple of marks to getting these, and then another couple of marks to getting your y values to go with them. Right, I am now off to go and watch Norwich come back and beat Liverpool 3-2.